Well, learners, let us develop the 3D version of modern periodic table. Here we have clay beads colored in various bright colors. You may use locally available material, maybe wooden beads or paper balls. You may make a hole in the center and string them together, and these beads make sure that you can write the symbols of the elements. So, let me string the first group elements together, and while doing so you have to keep the elements of the first period on top and arrange the rest in increasing order of atomic number. So, here my first group is ready, and well, when you string all the groups together, all you have to do is put them on a cardboard plank or maybe clay or even soil. Now that our strings are ready, let us see what shape the final 3D modern periodic table has taken. Wow! This is our 3D structure. What a beautiful model of modern periodic table we have here now. And well, I have used various beads made of clay. You can use different beads, and instead of these sticks, maybe you can use cycle spokes also or straw. And now you can make and play various games. Now, can you identify metalloids here? All the beads in pink are metalloids which are shown here: boron, silicon, germanium, arsenic, antimony, tellurium and polonium, all shown in pink colors. Likewise, even you can use different colors to distinguish metals and metalloids. And wow, look at these beads all in whites, the peace loving inert gases. And have you found the reason why hydrogen is placed in group 1 and not in group 17? Well, on paper, when we draw the periodic table, hydrogen is usually shown by broken lines, as it has properties similar to group 1 and group 17. So, it is given a special treatment. Now, can you help me locate the alkali metals? Yes, they are here in group 1. So, these are the alkali metals. And what about alkaline earth metals? Here they are. The group 2 elements, all of them are alkaline earth metals. So, I hope you are noting them down. So, group 13th is the boron family. It is boron family because its first element is boron. And what about the next group? Well, as you can see, the first element is carbon. So, it is the carbon family. And next comes the nitrogen family. And now you know why group 15 is called nitrogen family, because nitrogen is placed on the top. And then comes group 16th, the oxygen family. So, here is the oxygen family. You can also put flags when you make your own periodic table. And group 17th, they are halogens. And find out why they are called halogens. So, group 17th is the halogens. And well, lastly, we have the group 18, and they all are noble gases. They are even called inert gases. And well, children, in the center we have transition metals. So, transition metals, all of these starting from group 3 to group 12, all these are transition metals, and you will be studying about them in detail in senior classes. Well, children, once you make your 3D model, do not forget to add lanthanoids and actinoid series. Well, as you can see, they are continuation of 6th and 7th group. In 6th group, you can see in the 3rd period we have lanthanum. So, after lanthanum comes cerium, and then the 14 elements, that makes the lanthanoid group. And then here we have in the 7th period actinium, and then comes thorium, and that makes the actinoid group. So, they have complete 14 elements each in lanthanoid and actinoid. And well, visually impaired students should also be encouraged to participate and contribute in making of these beads. And definitely I am sure they will feel each and every element and know the exact position of elements in modern periodic table. Let us now discuss the various trends in modern periodic table. If we talk of valency and atomic size, how do you calculate the valency of an element from its electronic configuration? As you know, the valency of an element is determined by the number of valence electrons present in the outermost shell of an atom. As you can see here in the electronic configuration, the valency of all the elements in first group is 1. So, what is the valency of potassium, which is also in group 1? You can see here how the valency varies in going down a group. Well, it remains the same. Go ahead and find out valencies of first 20 elements. Now, if we look at the atomic size, the term atomic size refers to the atomic radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. Well, as you can see here, the atomic size increases down the group because a new shell is being added as we go down the group. This increases the distance between the outermost electrons and the nucleus so that the atomic size increases in spite of the increase in nuclear charge. Now, how does the valency vary in a period on going from left to right? Let us develop the electronic structure of second period elements. So, these are the elements in the second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. They are present in second period. Now, let us develop and write down their electronic configuration. Lithium has 3 electrons. So, let us arrange them. Well, 2 electrons will enter the first shell, that is the K shell, and the third electron will enter the next shell, L shell. So, let us write down the electronic configuration of lithium, that is 2 and 1. Now, next is beryllium having 4 electrons. So, where will this electron enter? In the second shell. So, here goes the electronic configuration of beryllium is 2, 2, and boron having 5 electrons, again it is being added in the same shell. So, notice the pattern that in this the extra electron is being added in the same shell. And what about carbon now? 2 electrons in the first shell and 4 electrons in the outermost shell. So, we can write down the electronic configuration as 2, 4. And next we have nitrogen with 5 electrons. So, it becomes 2, 5. Oxygen, 1 more electron will be added here. So, it is 2, 6. Fluorine having 9 electrons total, 2 go in the first shell and 7 electrons in the outermost shell. So, we write down 2, 7. And neon with 10 electrons, we have 8 electrons in the outermost shell. Well, children, you can also develop electronic configuration using locally available material. You can use clay, and for rings you can use string. And now, a very interesting pattern you have seen here. You can see that these elements of the second period do not have the same number of valence electrons. See, the valence electrons are increasing from 1 2, 3, 4, 5 and so on, but they contain the same number of shells. You also observe that number of valence shell electrons, they are increasing by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period. Another interesting feature is that you can find out which period the element belongs to by looking at these shells. Well, as you can see on the screen also, period number is equal to number of electron shells or orbits in an atom. So, here hydrogen, remember, it had only one shell. So, that is in the first period. Now, all these elements, they have two shells, as you can see. There are two shells. So, in which period will they be placed? Well, they all are placed in second period, as you can see here also. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, they all are in second period. And well, how many shells does aluminium have? That is right, 3 shells. So, it will be in the third period. Now, what about calcium? Do it yourself and verify. And well children, you can find out the position of any of the element. Now, coming back to second period, how does the atomic radius change as you move from left to right in a period? Okay, have a look at the electronic structures again of the second period elements. As we go from left to right, the number of electrons are increasing by 1, which means number of protons have also increased by 1. As a result, what happens? The atomic radius decreases in moving from left to right along a period. This is due to an increase in nuclear charge, which tends to pull the electrons closer to the nucleus and reduces the size of atom. Coming to the next property, metallic and non-metallic properties. Let us examine elements of the third period and classify them as metals and non-metals. On which side of the periodic table do you find the metals? Well, and on which side of the periodic table do you find the non-metals? As you can see, metals like sodium, potassium, magnesium, calcium, they all are towards the left hand side of the periodic table, and elements like sulfur and chlorine are found on the right hand side of the periodic table. In the middle, we have silicon, which is classified as a semi-metal or metalloid because it exhibits some properties of both metals and non-metals. Now, in modern periodic table, a zigzag line separates metals from non-metals. You can see it on the screen also. And the borderline elements, well, you can very well recognize from this 3D model of yours: boron, silicon, germanium, arsenic, antimony, tellurium and polonium. They are intermediate in properties and are called metalloids or semi-metals. Children, as you have seen in chapter metals and non-metals, all metals tend to lose electrons while forming bonds. That is, they are electropositive in nature. How do you think the tendency to lose electrons changes in a group? And how will this tendency change in a period? As the effective nuclear charge acting on the valence shell electrons increases across a period, the tendency to lose electrons will decrease. And down the group, the effective nuclear charge experienced by valence electrons is decreasing because the outermost electrons are farther away from the nucleus. Therefore, these can be lost easily. Metallic character decreases along a period and increases down the group. Here is an assessment question for you. By considering their position in periodic table, which one of the elements shown on the screen would you expect to have maximum metallic characteristic? Gallium, germanium, arsenic, selenium and beryllium? I am sure you can find out the answer. Now, non-metals on the other hand are electronegative. They tend to form bonds by gaining electrons. Let us learn about the variation of this property. Locate nitrogen. Well, here is nitrogen. And what about phosphorus? See, beneath this is phosphorus. So, the atomic number 7 nitrogen and atomic number 15 phosphorus, they belong to this 15th group of periodic table. Write down their electronic configuration. Find out which of these will have more electronegativity and why. How would the tendency to gain electrons change as you go from left to right across a period? And how would the tendency to gain electrons change as you go down the group? Well, I am sure you have guessed it. As the trends in electronegativity show, non-metals are found on the right hand side of the periodic table, and these trends also help us to predict the nature of oxides formed by the elements, because it is known to you that the oxides of metals are basic and that of non-metals are acidic in nature. Now it is time for self-assessment, or you may even do peer assessment. The position of 3 elements A, B and C in the periodic table are shown on the screen. You can see there are 2 groups, group 16 and 17, and 3 elements have been placed, A, B and C. Now you have to tell whether A is metal or non-metal, and also write down whether C is more reactive or less reactive than A. Well, will C be larger or smaller in size than B? And the last part is, which type of ion, cation or anion will be formed by element A? Now here is a task for you. Compare and contrast the arrangement of elements in Mendeleev's periodic table and the modern periodic table. And well, I know that you enjoy doing activities with your friends. So here is a group activity. The modern periodic law has been used to arrange elements in other ways too. Find out what are these. Now you are aware of long form of periodic table. It is a challenge for you to create your own periodic table, but you should be able to justify the position of elements and properties of elements and make it easier to understand. Now let us wind up the topic by discussing the merits of this table. To summarize, the periodic table is important because it is organized to provide a great deal of information about elements and how they relate to one another in an easy to use reference. As you will go up in higher classes, you will learn much more in detail, but this learning is the foundation of chemistry. You have taken initiative to know about scientific discoveries, and I am sure you have enjoyed the mesmerizing moments of meeting all the scientists of different time zones. Now, even you can predict the properties of elements, maybe some of those too that have not been discovered yet. You have learned that elements in the modern periodic table are arranged in 18 vertical columns called groups and 7 horizontal rows called periods. You have learned to classify elements on the basis of their repeating pattern of their chemical properties and relate it to the periodicity of properties including atomic size, valency or combining capacity, and metallic and non-metallic character. You have learnt many innovative ways of depicting modern periodic table. Now each one of you can write symbol of elements in large fonts on paper and hold it in your hands and spread out in the playground. and ooh la la, you will make a beautiful pattern of modern periodic table spread out in playground or field or any available open space. You can thus exhibit in various other innovative ways, think and create and depict your own periodic table. Rectangular periodic table you have seen. I have seen students developing circular periodic table also. So, let us see what kind of periodic table you will create. Well, children, you can also develop a science park or a science corner and exhibit your 3D model in activity room, in exhibitions or even in parent-teachers meetings. Visually impaired students may also be encouraged to contribute in making element beads and writing with embossed symbols with help of sighted buddies. You may display 2D and 3D models of periodic table on available surfaces, maybe pillars or poles in your ground, or maybe just group 1 or 2 as per the availability of space, and mention the properties of metals, because children visual learning takes place sometimes unconsciously. So, showcase the ideas of various learners, because when the child is engaged in hands-on, she or he is engrossed in the process, and it is the involvement of you children with the process of science which is more important than the final product, and this will create lifelong interest in you for science. Dear learners, if we talk of elements present today, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Now you know that elements in chemistry are similar to notes in music. Musical notes repeat at regular intervals, and so do chemical properties. So, you have realized and appreciated the interface of science with other disciplines such as music and especially Indian culture. Go ahead learners and learn to play harmonium, and maybe you can take out element beats on tabla too. Create your own poems, stories or maybe song on periodic table. Happy collaboration and happy learning.